the tangent button only works with the legs, and everybody remembers that that tangent button gives them a decimal that equals a fraction that then becomes this part of the measurements, yes? Okay. How did you do? Is this all right?
Yes.
Okay then.
Is Unit 1?
Yes. Everybody remembers this, yes? Okay, we're going to practice it right now. Okay? And I'm going to use this as a way to make sure everybody's calculator is in the right mode. Everybody tell me the tan of 81 degrees. And then draw an appropriate triangle to show that to me. If you don't remember how to do it, then you're just going to wait quietly while the people who do remember try it. What's the first step? I'm going to want my calculator here. Don't worry, Indigo, we'll sort that out. What is the first step to doing what I asked you to do? Which is find the tan of 81. What do I do? Karen. Excellent. It absolutely depends on my calculator, doesn't it? Do I have a forward calculator? So for me, I just go tan 81. Right? What if you have a backwards calculator? What do you do? 81 tan. Do I need to push equals?
Yes.
Yes. Do backwards calculator people need to push equals? No. Equals. Everybody cool? Yeah? Okay, you did not get 6.31? Okay, you have a fancy calculator. It's very similar to mine, yes? So, you need to push mode. Then use the little Nintendo controller to get down and highlight degree. Then you need to hit enter, enter. Everybody cool? Do you have a fancy calculator like this? Yeah, you do. It's got mode in the top left corner. Push mode. Now use the arrow keys to highlight the word degree. Then push enter. Then push clear, and then you'll be back to here. Now, where was I? Tan 81. So everybody should be seeing 6.31, yes? Now that means, since it is 6.31, in math, it's really 6.31 over 1, isn't it? Yeah. So now draw the triangle. Where would the 1 be? On the bottom. Where would the 6.31 be? On the right. And does that make sense? Because this is the angle we care about, and it would have to be 81. It would have to be very steep, wouldn't it? Is everybody cool? Mercy, did you get it sorted out? Yeah, I got it. Awesome. Is everybody cool? So everybody can deal with this. Okay, now remember, when we push the tan button, we find values for the legs. Is everyone good? Okay, now, notice in these first questions, I had an angle, didn't I? Yes, Gagan. Yes. No. We'll talk about that in a minute. Just the way we've been drawing them, the denominator has been that bottom side. Okay? But remember when we turned it around here? It's the legs. It's the opposite side is the denominator. Okay? All right, now, notice we had a degree here, yes? So we could draw the triangle, and we knew that this was 7, this was 10, and this was the angle we cared about, yes? Okay. Well, in this case, I don't have the angle, do I? What do I have? I have 0.75, which is the same as 75 over 100, correct? So if I drew that triangle, it would be 75 over 100. And I would need this angle right here, yes? Now, if my calculator can tell me the decimal when it knows the angle, then it must be able to tell me the angle if it knows the decimal, correct? Because your calculator can work backwards and forwards. So here's what we do. Everybody look at your calculator. Do not look at the buttons. Look at the actual calculator. What is written right above tan? Tan minus 1. Negative 1 is the opposite of 1, yes? Yes. So tan negative 1 is what will find me angles. Tan finds me sides. Tan is for legs. Tan negative 1 is for angles. Now, how do you access that part of your calculator, the stuff that's written on the calculator? Shift or second function. Or on my calculator, it just says second. Some of your calculators might have an INV. That's why this is hard to teach, because everyone's calculator is different. Okay? So now, knowing what you know about this, tell me, or try to tell me what this angle will be. You use the calculator the exact same way, forward or backwards. When it was just tan, you push tan 35. Well, what are you going to push now? Shift, whatever your shift button is, tan, and then what are you going to put here? 0.75. And then equals if you've got a forward calculator. What if you're a backwards calculator? 0.75, shift, tan. And what do you get? 36.86. Now, in angles, just like feet, we don't use decimals. Angles are broken down. Does anybody know what angles are broken down into? Because we don't use decimals. Does anybody know?
Fractions, maybe?
Kind of fractions. Anybody? Kind of fractions. Angles are broken down into minutes and seconds, like time. There are 60 minutes in an angle and 60 seconds in every minute. Because a clock has 360 degrees, which is all the degrees you need. Right? Okay. So since we don't use decimals, when we're going to an angle, we just round it off. Everybody cool? Okay, now, what's weird about B? There's a negative. Do you think you do anything differently with your calculator when the number looks weird? No. So everybody try to punch that in, and then try to punch in C, and tell me what you get. What do you get here for B? With a negative? It's okay, Maddie. That's why we're practicing. What do you get? Negative 50.8, which is negative 51, right? Okay. And what do you get here? Adrian? 68.19, so 68. Is everybody cool? Okay. Which of those two angles bothers you? The negative 51, yes? Because 68's easy. I draw a line, then I go up 68 degrees, and there's my angle, yeah? Okay. So what? Now, this is really only for grade 11, but I want to show it to you anyway. It's negative. Can I go up? No. So what direction should I go? Down. Okay. So I go down. How far? 51 degrees. Everybody cool with that? That still makes no sense, doesn't it? No. Until you do this. How many degrees in a whole circle? 360. So if I go up like we're used to going, and I go all the way around to here, what have I done? 360. But I didn't go all the way around. I stopped where? I stopped 51 degrees shy of all the way around, didn't I?
Yeah.
So what math would I do to find this red side? If all the way around is 360, but I stopped here, subtraction. So this red angle is 309 degrees. Everybody cool? And like I say, that happens in grade 11. And look, tan of negative 51, which is what we just did, right? Negative 1.23. So what then will be the tan of 309? What will be the tan of 309? Negative 1.23, because it's the exact same spot in the circle. Everybody understand? But that is really for grade 11. But I wanted you to see it to let you know what's coming for you. Negative angles will exist. Everybody good? Okay. Because if I go all the way around the circle, gang, and how far have I gone? 360 degrees, right? And if I was just measuring 51 degrees, I would start at this flat line and go up, right? But since it's negative 51, I'm going to go down, which means my line is going to stop 51 degrees this way. So my red circle doesn't go all the way around. It has to stop right there, which is 51 degrees short of 360. So it's 309. Okay? All right. Everybody cool? Okay. Now, let's talk about this. For any specific angle, what is the one angle tan can't work with? Yeah, I can't do anything with the hypotenuse because the hypotenuse is not, there's not two of them, is there? So this cannot work with the angle that deals with the hypotenuse. What angle is attached to the hypotenuse? How do we use one of the angles in a triangle to find the hypotenuse? The right angle, right? So the specific angle means not the right angle. Has to be one of the other two, right? So now, here's our triangle that we're used to using. Is that one of the 90-degree angles? Or is that a 90-degree angle? No. And if we were going to do tan with that, we would need that side, right? Because that's a leg. And that side, because that's a leg, right? What do we call the side that is across the triangle? Opposite. It compares the opposite leg, because opposite means across. And what does it compare that leg to? Does it compare it to the hypotenuse? It compares it to this guy, right? So what do we call that guy? The adjacent leg. And notice they are both legs. Tan will never help you with the hypotenuse directly. But if tan gives us this side and this side, can we then use that to find the hypotenuse? Yes. Is everyone cool? All right. Now, let's see if you can really handle this. Where in this triangle is angle A? Top, left, or right? Top. Excellent. If I care about angle A, then this is where I am. I'm not blue. I'm very happy today. Blue. I'm not blue, but I do have gray hair. There I am, yes? Because I care about angle A. Yeah? So you tell me, what is the tangent ratio of angle A? Tan A, we know, is opposite leg over adjacent leg. Op over adjacent. So, what would I write in that fraction? 12 over 5. Why, Marcos? opposite across the way is 12, and the other leg is 5. Everybody cool? All right. Now, what happens when I say, because you guys know how cool I am, I see a slide. What am I going to do?
You're gonna go down it.
Damn right I'm going to go down it. I'm not one of those punk kids that goes up the slide. I'm going to slide down. Woo! And now I'm down at B. What is the tan of B? Is it still opposite over adjacent?
Yeah.
Yeah, because tan is always opposite over adjacent.
So it'd be
But are the numbers the same?
no.
What's opposite to me now? 5. What's adjacent to me now? 12. So, what's the lesson here? The numbers change depending on where I am in the triangle. But the names of the sides don't. Is everybody cool?
Yep.
All right. Now, using these ratios, I want you to find me the angles. If I'm looking for angles, is it tan or is it shift tan? It is shift tan. So you now talk with your neighbor and see if you can use those decimals. I just gave it away. Those fractions to find the angles.
Okay, so you just
Shift tan of A equals what? And shift tan of B equals what? Try and figure it out. I haven't shown you how. I want to see what you come up with, even though I just gave it away by saying what I just said 2 seconds ago. But most of you have already forgotten that, so it's okay.
not really. Still.
No, you said decimal.
It's gonna
I did say decimals.
It's gonna haunt me forever.
Yeah, and after that you said okay.
Exactly.
Whoa, like it just swear.
No. I say crap all the time.
Whoa, calm down, crap.
Crap, crappity, crap. It's like that in the Smurfs, in the first Smurf movie where Hefty goes, Smurf you! And all of them said, there's no need for that language. All right. So, what did I need to do with this blue? I needed to do division, didn't I?
Yeah.
Because if I know this decimal, can I then use my shift tan? What is 12 divided by 5? 2.4. What is 5 divided by 12?
Oh, I never did that one. Hold up.
0.416. Forever, right? So we'll stop at 416. Everybody cool? Okay. Now, once you have that decimal, what do you do here?
Click 10.
Shift tan and then the decimal, correct?
Yep.
Now, all of you like shortcuts. It's your favorite thing in math class. I don't know why, but it is. So, would you like to see a nice little shortcut for these? I'm going to show you anyway. You don't really have a choice. This is shift tan of 12 divided by 5, yes?
Yep.
So let's go to my calculator. Shift. I have a forward calculator, so I can just go the way it's written, right? Shift tan. And instead of the decimal, why don't I just go 12 divided by 5 and close the brackets? Is that going to do that 12 divided by 5 first? Yeah, because it's in brackets. Didn't I have to do 12 divided by 5 anyway? And then when I push equals, 67. So what am I going to do for the red one? Shift, tan, then what? 5 divided by 12. Close brackets. I just did 5 divided by 2. 12, close brackets, enter, 23. Everybody cool? Now listen to me. The next thing that it says there, I actually want you to do. Because everyone's calculator is different. So what I had to punch on my calculator to do these, I had to push second, not shift. I have second. Then I had to push the tan button. Then I had to push 12. Then divided by, don't write down what I'm writing down. This is what my calculator did. divided by 5, close bracket, equals. What did you have to punch?
Are you talking about backwards people?
Backwards people, forwards people, whatever. If you're a backwards person, you obviously reverse it, right?
Yeah.
So you must go bracket,
Yeah.
what?
5. 12.
12 or 5, whichever. 12 divided by 5, close brackets, then what?
Shift 10.
Second, tan, then what?
That's it. And then
No.
we didn't have to click equals.
Is this the same?
Oh, yeah, no, okay, yeah. All right.
You gotta push equals then,
Brackets, yeah.
right? Because of the brackets. Is everybody cool with the first scratching of the trig surface?
Pretty wide.
Can everybody do tan?
Yeah.
Okay, let's have a look at this question. Let's make sure. Then I'm going to let you go on your own a bit. In this question, I have, what's that? Leg or angle? Leg. What's that? Leg. What's that? Angle. Excellent. So, in math, in trig, whenever there's an angle that we care about, we give it a Greek letter. I don't know why, we just do. The Greek letter is that. That letter is called theta.
Why?
Just 'cause. Theta is what we have decided is the symbol we use for the angle that we care about. And right now, we care about that angle, don't we? So our theta equals x, because that's the angle we want, and its value right now is x. Does everyone understand? Great. What would you call that 23 compared to that x? Because that x is where I am, because that's the angle we care about. What would you call that 23? It's an opposite. So I can write opposite equals 23. What would you call that 15? Adjacent. So adjacent equals 15. Now, do I need an angle or a side? Angle. So is it shift tan or tan? Shift tan. And it's the exact thing we just did, isn't it? So, shift tan of what? 23 over 15. What's our value there? So 56.88. So we round angles off to the nearest angle. So what is it, Deanna? 57. Nice work. Is everybody good? Now, if your calculator doesn't say 57, well, 56.88, blah, 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 you know you're in the wrong mode, yes?
Yeah.
Is everybody still in the right mode? Sweet! Now, let's look at the second triangle. What's the same? It's a triangle. What else is the same? Do I have an angle that I care about?
Yeah.
Do I have a side that I care about?
Yeah.
Do I have another side that I care about?
Yeah.
So is anything really different? So if I do almost the same stuff, am I going to be okay?
Yeah.
Great. Let's start. What is theta? The angle I care about. What is it? 15. Because it tells me that's the angle right there. So here I am. I've got blue hair now because I'm a punk. There we go. Now, since I'm up here, this is how we're looking at the triangle, yes? So what is that? Opposite equals what? X. What is that? Adjacent equals what? 37. And I know that tan of theta, the angle I want, is O over A, yes? Great. So what's theta? Tan of 15 equals what's O?
X.
Over what? 37. Now, if we were doing algebra and we had a number under a variable, what gets rid of that divided by 37? Times 37. They cancel, yes? If I multiply the right side, what do I do to the left side? Same thing. 37 tan 15 will give me x, won't it? So, what math is happening right there? Multiply. Some of your calculators you'll need to push 37 times. Some of them they won't. My forward calculator doesn't make me do that. On my forward calculator that I wish would just work instead of having to turn it off and on every time. 37 tan 15. Close the bracket, equals 9.9. If you have a backwards calculator, you're going to go 15 tan times 37 equals. And you should be getting 9.9.
Yep.
So x equals 9.9. Is everybody cool?
Getting less cool, getting a little warm. So you might need to take off my jacket.
What about this triangle? Is it the same?
Yeah.
It's very similar. Is there an angle that I care about?
Yeah.
What is it? 70. So if this is the angle I care about, what letter am I going to be standing beside? H. So here I am. Now I've got green hair because I'm still a punk.
Jeez, you really don't like
Right?
colored hair.
So now, no. Not punk in a bad way. Punk in that back in the day, when punk first came out, punks had mohawks and dyed their hair.
I thought you were talking about
No, I don't mean like what punk means now. I mean what punk really means.
like punk rock.
Yes, like punk rock. So what's that? So what's my O equal? 14. What's the X? A. So that's X. Then, tan of what? Tan theta equals O over A, right? Fill it in. What's the theta? 70. What's the O? 14. What's the A? X. Now, when it was the number on the bottom, we multiplied. What do we do here? We've done this to death already this year. It's divide now, yes?
Times.
So it is 14 divided by tan 70 equals X. And you do that in your calculator, however you do it. Backwards, 14 divided by 70 tan equals. Forwards, 14 divided by tan 70 equals. And what do you get? 14 divided by tan 70. 5.1. Now, remember, we should always see if it makes sense, yes? Does that make sense? Does that make sense? It's not longer than 14, right? So we didn't screw up there, right? And if I'm making a 70-degree angle, I got to go almost all the way up to 90, don't I? So it's got to be a pretty steep triangle. So this has to be quite a bit shorter than this, doesn't it? And we're okay. Is everyone good? All right, now with your partner, try to do number 5. Actually, I lie. You're going to do all of page 55. That is the rest of your work today. And if you don't get it done in 8 minutes, that's homework. Just 55. Okay?
Got it.
Go.